Hello, everybody. We are in week 3 of Introduction to Business Statistics. And this week's topic is probability. Things are going to get a little bit more hairy from this point on in. Oh, I shouldn't say that. I don't know that for a fact. But I know probabilities. I was never real good at this topic in college. And I still struggle with them a little bit today. However, I think you're going to find that the work that you need to do is not too difficult. The interpretation might be a little bit more difficult, but let's dig in. In just a minute, I'm going to switch to my overhead camera and discuss probability a little bit more in depth. But what I want to first do is generate the data we need for problem number 1. What we need are frequency distributions. And we did those before. We did those in week 2, and you may still have them, and you can use them. Do we have the right ones? Yeah, I think you do. I'm going to use a set of data tonight for this video. That's not something you will be using for your homework this week. However, what you're looking for is the technique, how I'm doing this, and how we're using the data. That's what you want to learn from this video. What I'm going to use is the data over in column 1. And that's our friendly Springdale Mall, the mall that everybody seems to love. And we're looking at the frequency, and that's how many times people go shopping there. So let's generate that frequency distribution. Let's see, as you recall, that's on the data tab. In our data analysis, we have something called histogram. Doesn't sound like frequency distribution, but it is. We say OK, and first we need to define where our data is. The labels thing is checked, so I'm going to grab the label and scan on down over that column. And now we need to define what they call the bin range. Nobody has come up with what that word bin means yet. Suppose I could Google it, might find it. Anyway, that's our range of values. And let's see, for this piece of information, they only range from 1 to 6, and so I don't need that value 7. That was when we were working with spending. Then there was a category 7, but not in this one. So for my bin range, I'm simply going to grab the title value and scroll down to 6. I want this in a new worksheet, and I don't need a chart. I just need the frequency distribution. I say OK, and there's our frequency distribution. Okay, we've got this annoying more category that, I don't know, we've never had anything in more. I guess it depends on what your data set looks like, so I'm just going to delete that. These underlines bug me, but I know that on the Home tab, it's the Borders button. And yeah, we can simply select No Borders to get rid of those little underlined stupid things. Okay, I know I'm going to need a sum of these frequencies. And so let's see, how many is that going to be? Can you tell me? Well, you should know. Remember, this is just the sum of all. These are all the different survey responses. So if we simply sum those up, we should get how many? That's right, 150 respondents. And sure enough, there are. Okay, let's clean this up. Instead of value, what am I really got here? I'm looking at shopping frequency, right? Number of times shopping. Ooh, I think I said spopping. Yeah, we'll clean that up. Shopping. And let's see, now what do these things represent? Well, I have to check my book, and the first one is 6 or more times per month. That's how many times category 1 people go to the mall. So that was 6 or more, greater than or equal to 6. And I will, I'll just clean things up a little bit. I'm going to do one other thing over here. In this category, I'm going to calculate what's called a relative frequency. And all I'm going to do is take and divide the frequency by the total number of times number of responses. So I'm going to say equal that cell divided by this cell, and it gives me a number, and then I can use autofill to copy that down, and oh, got a mistake. What happened? Well, I forgot about relative cell referencing. If I look in one of these, I'm getting into edit mode. I'm trying to divide by this cell. Yeah, well, this is an Excel class. But anyway, what I need to do is make that B8 an absolute cell reference. So I will simply put, by hitting F4, I'll put $signs around that B8 address. And now, when I copy that, each cell you can see says $B, $8, and I've got my values. All right, let's make these a little bit more reasonable. I will get rid of a couple decimal places. I'm going to center that data as well. Don't like those underlines anywhere. Okay, hold on 1 second. I'm going to do a little more cleanup. Hello again, I'm back. Well, we've got some multimedia going here now, don't we? I hope it's all working. Okay, I've cleaned up our graph a little bit. I just filled in what these values from our frequency distribution really mean. It's the number of times a person went shopping, greater than 6 per week. I didn't say per week on that one, did I? Oh, not that it really matters. Per WK. All right. Down to at the low end, 0 to 1 times per month. And we had these values in here before. This is the frequency. This is our frequency distribution that we generated using our shopping data. And I calculated what's called a relative frequency, where I simply took the frequency and divided by the total number of surveys, 150 of them. Okay, now let's talk about probability. Your author talked about probability, and let's see, I don't want to fall off the screen here, get this situated right. The probability of some event occurring is classically thought of as being the number of favorable outcomes. Ooh, falling off already. Outcomes divided by the total. Looks like I need a more fine point pen. Total number of outcomes. This, by the way, is my brand new $4 whiteboard from Target. Sure beats drawn on paper. Okay, so let's do an example. Let's talk about rolling a single dice. Dice has 6 times. What is the probability that I will roll 4? Again, we have a single dice. So how many favorable outcomes are there? If I'm looking for a 4, there's only one outcome. What's the total number of outcomes that can occur? Well, on a die, that's 6. And so I'm looking off screen at my calculator. That's equal to 0.167 or 16.7%. Okay, let's mix it up a little bit. How about the probability that I roll 4 or 6? Well, how many favorable outcomes can I have? Well, there's 2 of them. Nice eraser. There's either 4 or 6. There's 2 possible favorable outcomes. There's still 6 total. We have 1 die. It's got 6 sides. And so that's a third, or about 33%. That's the probability of rolling a 4 or a 6. Okay, let's extend that to the data that we see ahead of us. Ooh, that's kind of tricky, isn't it? Kind of bizarre, actually. Let's extend that. Let's look at this number right here and say, what's the probability that someone in our survey goes to the mall 1 time per week. Well, let's write that as a probability statement. Probability of once per week. Well, how many favorable outcomes are there? Well, we can see from our table, there are 26 favorable outcomes. 26 people go to the mall once per week. What's the total number of outcomes? Well, that's our total number of surveys, 56. Speaking and thinking and writing all at the same time, it's 150. So 26 divided by 150. If I did that right, oh boy, didn't do that right. 26 divided by 150 equals roughly 17.3%. The probability is roughly 17.3% that someone in our survey goes to the mall once per week. Okay. How about the probability that they go, well, let's stick with once per week, or 0 to 1 times per week. No, 0 to 1 times per month. Well, isn't this like the die where we were looking for a 4 or a 6? Yes, it is. We can simply add values from our table. So once per week, that would be our friend 26. And we're going to add to that 0 to 1 times per month. That's 37. We still have a total possible outcomes of 150. And so we do the math. 26 plus 37 equals divided by 150. And we find the probability of that is 42%. Now, let's do one more simple one. Let's do one like the first one. Let's just look at a simple case. Let's look at the probability of going to the mall 4 to 5 times per week. And let's see, that's a single number. That would be 7 over 150. And what percentage is that? 7 divided by 150 is equal to 0.047, 2 decimal places, or about 4.7%. Now, what some of you might have noticed if you're watching this is that this 17.3 for our probability of once per week, here's our probability of once per week, looks a lot like that number. In fact, it is the same number. Let's get another decimal place here. There we go. 17.3. That's right there. And our probability of 4 to 5 times per week. 4 to 5, that's 0.047. There it is, 0.047. So the relative frequency comes in handy. You can do it either way. It doesn't matter if you just want to add the numbers, but if you want to calculate the relative frequency, you can. Let's do one last one. I want to know the probability. See, how do I say this? That the person goes more than 0 to 1 times per month. All right. How does that work? Well, here's our 0 to 1 times per month. That's 37 times. But we want not that they go 0 to 1 times per month, but that they go more than that. Well, we have a couple options here. one thing we can do is we could add up all these values. 50 plus 26, 27, 7 and 3. And we should probably do that. Let's see, there's 150, and if we subtract 37, that'd be 120, 113. Did I do that right? Please holler. I know, you can't holler. Well, you can, but it doesn't do much. Let me double check that. 150, that'd be 120, 113. Yeah, okay. So let's look at that probability. 113 divided by 150, our total number of possible outcomes. There's a 75% probability. 0.753 or 75.3%. Now there's another way to do this. And when we're looking at these endpoints, or we're looking at one value versus all the rest, we can do a slight trick and we can say the probability, it's the same thing, more than 0 to once per month is equal to 1 minus the probability of 0 to 1 per month. Does that work out? Let's see. Well, let's see. 1 minus, and the probability of 0 to 1 is, we know, 0.247, 0.247. Now let's do the math. 1 minus 0.247 is equal to, look at that, 0.753. Oh, I'm falling off the table, sorry. Or 75.3%. Yeah, I heard you screaming. Move it up, move it up. No, didn't really hear you screaming. Shocker. Okay, so did we have to do that? No, we could have just relied on adding up all those values because that always works. All right, let me take a breather here. Okay, just a couple final notes. I'm going to wrap this up, and I'm going to do our other type of problem in another video. If you're looking for some more videos, I did probability videos for my other class, the 109 class at CSU Global. If you are looking for some other videos, just need some extra information, perhaps those, oh, my memory is going. The homework problems that you do each week, mastery exercises. If there's some probability work in there, I haven't looked this week yet. There might be some help for you in the videos that I've done in the past. You could check those out if you like. If you want to find those, just search by my name on YouTube and they should all pop up. There should be 30 or 40 of those things by now. Finally, just a couple comments about our CT problems. In general, we've been doing really well. Keep it up. I sent back the week 2 one just hours or so ago, and there were a lot of really high numbers. You guys are doing great. APA. Is Craig a stickler for APA? Do you think? Yes. You know, if I was you, if I was one of you, I would learn how to do APA, because once you learn it, you'll use it forever. Well, at least in every class at CSU Global, and you'll never lose another point for APA formatting again. I know it's kind of a pain, but you know, you write 1 or 2 papers where you spend the time looking how to do it, and you'll never have to look again. It's pretty simple once you've done it. I think you'll find that. So that's my recommendation to you. As our work gets more difficult, you're going to start losing some points due to not doing the math work right. At least that's my guess. But I could be all wrong there, but that's my guess. However, if you are losing points for the math work, doing APA correctly is a no-brainer way to keep your grades up high. That's all, folks. Hope this helps.